So, as you know, this is electrical circuits. Just now, Dr. Jamal finished the electronics semiconductors. Now, I will just concentrate on the basic principles and many problems, how they can be asked in the exam. So, already this the material, these are the syllabus what I already shared with you in the video. This we have to concentrate for the exam. Means like resistor, inductors, and capacitors, and what is Ohm's law, what is Kirchhoff's laws, and what is the power equation, and what are the mesh analysis, node analysis, Thevenin's and Norton's theorem. Then go for the AC analysis like reactance. So like this RLC circuit we have to check. So already I gave the formulas for each item, that is for the Ohm's law. This is V is equal to IR, and we can rearrange this one, I with the R. Then these are the two equations. So already this you know it. What is the resistance basic equation? R is equal to rho L by A. That is resistivity times length divided by area. That is resistance based upon the material, its length and area and the material. So this already you studied, but we go for the, just remember this slide with the equations, then we'll go for the problems. So what is Ohm's law? V is equal to IR. We have to remember this. And what is the resistance equation? Rho L by A, where L is the length, A is the area, and rho is called resistivity of the material. That we cannot remember, but it is given in the exam if it is applicable in the question, because each material have different resistivity with the very small value. We cannot remember that one. And when the two resistors connected in series or many resistors connected in series, what is the principle? We have to remember the resistance will be adding R1 plus R2 plus R3, go on, and voltage will divide V1, V2 and V3. Like this, voltage will divide with a common current, constant common current. The current will be same for all the resistances. So like this, you have to remember the key concepts. So resistance will be R1 plus R2 and go on. And voltage will also V1 plus V2, V3 based upon the number of resistors connected. And current will be same. I is equal to I1, I2, I3. All currents will be same. In series circuit, current will be same. Now same go to the parallel. If the two parallel resistors or more parallel resistors are there, the current will divide here, but voltage will be same in all the resistance branches. So here quite opposite. Here voltage is different. Here current is different. It will divide. It will divide based upon the resistance value. The current will divide, but voltage will be same in all the parallel branches. So here same. Here see 1 by R is the total. That is 1 by R1 plus 1 by R2 plus 1 by R3. We have to just reverse the resistance value and add all the resistances. And at the end, don't forget to again reverse it, because I shown you simply way. If 2 or 3 resistors are in parallel, then you have to make a X, that is reverse it and add it like your series. Add it, but after reversing. But at the end, again reverse it back, so it will get the equivalent resistance for the parallel resistance. Current here will be total current is nothing but I1 plus I2 plus I3 means different branches. What are the currents? It's a summation. Is the total current. Voltage will be V1 equal to V2 is equal to V3. Okay, so now power. So we know the what is Ohm's law, we know the what is resistance, we know the series resistance, we know the parallel resistance. Now come to the power. If this is a resistance or something, power is nothing but V multiplied by I. Power is equal to V multiplied by I. Current is entering that element, maybe resistance, maybe inductance, whatever may be. Current is entering that element is nothing but plus power, means it absorbs. Plus means it takes, absorb. When current leaving that element current is leaving out, then it is minus VI, means power delivered, giving out. Like generating station, give the power. Like our heaters, AC, projector, what it will take? It will take the power. So current enters inside. So that's called plus VI. So what is the equation? P is equal to VI. If we rearrange V with Ohm's law, what is V? IR. Substitute here IR, I square R. Now substitute I as per the Ohm's law, V by R. Substitute V by R is nothing but V square by R. V. So like this, these equations you have to remember. Then go to the problem. What is the first problem? I'll read it. Dash is a current that alternates with time. So with time, which currents will alternate? We have options. generally current or DC current or power or AC current. It's a alternating current. AC full form itself alternating current, which will alternate from positive cycle and negative cycle. Positive cycle, negative. This is called alternating current. And DC is nothing but direct current, which doesn't alternate with the time. So the current which alternates with time is called AC current. And the voltage across 1.1 kilowatt, 1.1 kilowatt toaster. Toaster means the brick toaster is there, some device. Toaster that produce a current of 10 amperes is. So what is the voltage? Power equation. P is equal to V times I, right? So what we know? P knows. What we know? I knows. It is nothing but P divided by I. So here, what is the general confusion is you never change this kilowatt to normal values because current is in ampere, but power in kilowatts. So first you have to transform it. 1100 Taksim Ashra generally. Okay, so it becomes Mi Ashra 110. Next, as the length of the wire increases, what happens to its resistance? What is the resistance equation? R equal to rho L by A, right? So length is directly proportional. Length is directly proportional to resistance. So length is increasing. So what happens to resistance? It automatically same. In the same ratio, it will increase. If length is double, resistance is double. If length is half, resistance is half. It depends. It's linked like that. Increases, remains constant, decreases, fluctuates, means changes. So increases. A is the answer. What is the voltage across 10 ohm resistors in the current flowing through it is 2 amperes. What is the voltage across 10 ohms resistor if the current flowing through it is 2 amperes? Ohm's law. It's a Ohm's law, right? So V is equal to I R. So what we need? Voltage multiplied by 10 multiplied by 2. So it's a 20 volts. C is the answer. Starting will be simple only, the later it will add. If the resistance in a circuit increases while the voltage remains constant, if the resistance in a circuit is increasing, then the voltage what we are applying is constant. We are not changing. Only resistance we are changing, increasing the two. Then what happens to the current? Ohm's law. V is equal to I R, right? If resistance is more, current will go downside. So inversely proportional. So it will decrease. So decreases. C is the answer. Okay, now in the figure, all resistances are 5 ohms, then find the R equivalent. Now you have to check it. So this is your figure. We have 2 resistance, 1, 2, 3, 4, 5, 6 resistance are there. So by seeing from this end, what is the equivalent resistance? First, step by step, you have to solve. We can draw new circuits also, so that you can easily get the result. So first you have to solve these two. What is these two are in series? So 5 plus 5, all are 5. So 10 ohms. Okay, these two resistance comes in 10 ohms and this become parallel with 5 ohms. 10 and 5 parallel. So 5 into 10 divided by 5 plus 10, 15. So some 3.33 something it will come. So next, this 3.33 resistance, again series with the R, 5 ohms. So 5 plus 3.33, 8.33 something will come. So then once this 8.33 is a resultant, will be parallel with another 5. So 5 multiplied by 8.33, Taksim 5 plus 8.33, 13.33. Okay. So then it will come, I think, 3.125. It will come 3.125. Then this 3.125 is series with the 5 ohms. So 5 plus 3, it is 8.125 is the resistance. Final answer. You can check it. You must use calculator for this. And calculator is not allowed, but on the screen there is a calculator button is there. You can use that one. Okay, all options will be there. Under root, sine, cos, everything will be there in that. You can use that. You cannot. It's not allowed. It's clearly told. Okay. Okay. Two resistors, 6 ohms and 12 ohms are connected in parallel. So sometimes the circuit is not given. Sometimes in verbally they will explain. 2 are series, 2 are parallel. So be sure that what he is exactly telling. Okay, what he is exactly asking. What is asking? 2 resistors, 6 ohms and 12 ohms. We have 2 resistors, 6 ohms and 12 ohms are connected in parallel. So like this, parallel they are connected. the equivalent resistance is then connected. Means once this parallel resistance got equivalent resistance, one result will come that is connected in series with 4 ohms. So what is the first step we have to do? We have to finish that parallel path, then add with the series path. So if you 6 and 12, when you make it parallel, 6 multiplied by 12, Taksim 6 plus 12. So 18. So 6, 18, 3. So 3 and this 12, 4. So 4 ohms is the result. Division. Here. 6 and 12, make it parallel. So how we will do the parallel equation? Multiply and divided by Jama. Okay. On the 4, multiply each resistance. If 2 we have, the Taksim Jama. So we will get this 2 resultant as 4 ohms, Arba ohms. Then the result is connected in series with 4. So 4 plus 4, how much? 8. So that will be the answer. 8 ohms is the answer. So now, last one. A 5 ohm resistor in series with a parallel combination of 3 resistors. 10, 20 and 30. These are in parallel combination, which is in series with the 5 ohms. So here, slightly opposite. First, we have to do the parallel combination. Okay, then series. So, because these 3 are first in parallel, that is connected in series. See the wordings is just slightly opposite. So, first make these 3 in parallel. Easy way, when more than 2 resistance are in parallel, then easy way what I told you, make 1 by of each resistance, Jama it, then again 1 by. So, what is 1 by 10? 0.1. What is 1 by 20? 0.2. Right? Yeah, 0.5. 1 by 20, how much? 0.5? 0.05. 0.5, right? So, this is 0.1, this is 0.5. 0.05, right? Yeah, 0.05, yes, 0.05. Then 1 by 30, some 0.033 something will come. So, now add all together, 0.1, 0.05, 0.0333. Then, you will get the result. Make again reverse. That you have to add with the 5 ohm resistance, then you will get the resultant. And it is generally, I think, I don't know answer, you have to check it. 10 ohms?
Yes, this is the
yeah.
Resistance, it will be 5.45.
Okay.
5 plus 5 will be 10.
Yeah, around it is 10. That is A. Yeah, around. Sometimes you may ask around, nearby. So you can use that 10. So see the answers? Yeah, around 10, correct. So these are the answers. First one is D, that is AC current. Second one is 110 volts and increases when length increases. Then C, that is 20 volts. Then A, that is increases. Then D, yes, 8.125. Again D, 8 ohms. Again A, 10 ohms. So like this, for the series parallel combination, Ohm's law and power, like this the questions will come. So next step, we will go for the what we call branches, nodes, KCL and KVL, Kirchhoff's voltage, Kirchhoff's current law, branch, node, mesh, loops will in that format what it will be there. So in this you can see how many branches are there. Branch means it is connected in between any 2 nodes, or a branch may be element, may be a source. We don't know. So both are same. Branch means either a element means resistance, inductance, capacitance. These are the elements. Sources, voltage source, current source, dependent voltage source, dependent current source. These are the sources. Okay. All are called branch only. Okay. Individually, these are all branch. So like here, voltage source and resistance, not one branch. It is different branches. So source one branch, this is the resistance, another branch, another branch, another branch, another branch. Now, what is a node? Node means when 2 branches connected together, common is called node. Node must have a branch in between or connected to it. For example, this point and this point, is there any branch in between? No. So this is not count as a branch, or it is not counted as a different node. It is a common node. It become a common node. So we have to be careful. When there is no branch in between these nodes, first we make it arbitrary nodes, no problem. But we have to see in between, is there any branch or not. If there is no branch, make merge. So that become common node, one node. So these 3 will become one common node, that is B. And this all 4 will become one common node, C. So like this is called node, this is called branches. Now loops. Loops is nothing but from branch when starting to finish in the same branch. This is A to B from 2 ohms, so then C and coming back to A. This is one loop. It should not repeat the same node. It should not repeat the same node. So a node is a point of connection between two or more branches. A branch is representing single element such as voltage source or resistance. Okay. Next, this equation is very important for you. You have to remember this. Number of branches, number of loops, number of nodes. So branches, generally we have to remember how many branches are there if given circuit. That is given by number of loops plus number of nodes minus 1. Loops, nodes minus 1. We have only 3 items: branch, node, loop. So we have to remember on the left hand side branch is there is equal to, remember that number of loops, number of nodes, because in any analysis we need nodes, we need loops in any analysis. Branch is given, already it's given. So put branch on the left side. On the right side, analysis items. What are the analysis items? Loops and nodes. So loops plus nodes minus 1, you can remember easily. Okay. Otherwise, what is on the left, on the right, we don't know. So P equal to L plus N minus 1. On this, some questions will come. So now what is Kirchhoff's current law? For the particular node, the number of branches connected, the current entering summation is equal to the currents leaving summation. Or you can put one side only. The currents summation is equal to 0. Entering current is positive, leaving current is minus, negative, we can say. Anyway, you can assume. So for this one, current entering is I1 and I4 and I3 also. Current entering I3, I4, I1 is entering. So equal to current leaving I2 and I5. So like this case here. Okay. So now what is loop? Loop equation is nothing but starting leaving the current leaving from the positive sign, we'll take it as a negative voltage. Negative voltage drop, generally we call. Current entering in the positive sign, it is called positive drop. So as per that, this will become minus V1 and this become plus V2, this become plus V3 and current leaving. So minus V4, current entering plus V5. So like this, you have to form equation, then you will get easily. Once you get the correct equation, in the calculator, we have equation format also. Just give the equation, you will give the result. No need to solve also. We have different methods to solve, it will take time also. We have Rangakutta method, we have elimination method, we have Cramer's rule method, matrix method. But in latest calculator, I'm telling about calculator usage. In the calculators, we have give the equation, first equation, second equation, third equation, 3 unknowns. Then you will give the answer, I1, I2, I3, or V1, V2, V3. It will give. So easy that one. So like this, the sum of the voltages, now as per this, we can arrange a KVL like voltages, positive voltages on the left hand side, negative voltage on the right hand side, or sum of the all voltages equal to 0. How the sum of the all voltages? If the current leaving from the branch, then from the branch positive terminal, it is a positive voltage. Current entering in the positive terminal of that branch, it is a negative voltage equal to 0. Sum of all this equal to 0. So like this we have, and it's okay. Now come to the problems. Oh, another loop analysis. Generally node analysis. This node analysis, generally we have to take one less node to analyze. Generally one common node, you take it as a ground. Then you write the node equations for remaining nodes. How many nodes we have? 1, 2, 3 nodes we have generally, right? As per this equation. But we form node equations less than the minus 1, means 1 less than the number of nodes. 1 less than the number of nodes. Here 3 we have, we need only 2 node equations. Then we can get the voltages everywhere. What are the voltages of the different branches and what are the currents we can know. So with these node equations, what we will find? Currents. KCL apply for the nodes and KVL apply for the loop. KVL voltage, right? Okay, mesh also we call. Okay, so here see, in this we another mesh analysis. This is node analysis, this is mesh analysis. Here we are forming from this point to this point and this point and this point. So one loop. And from this point to the this resistance and this resistance, voltage source and resistance, another loop. Okay, so they write the equation. Current, the I1, current leaving means minus 15. Now we can form assume plus minus our own. Generally resistance plus minus will be left and right side. Current enters in the resistance. So we can put plus minus here, we can put plus minus here, we can put plus minus here, or we can put reverse also. In the result it will show it is negative or positive. In the final answer it will show. So minus 15 plus we are forming small I1. So 5 I1 minus 15 because current enters 5 I1. Now we have come to here, current enters plus minus. I am assuming like this. So 10 I1 minus I2 because two currents are going here. So I1 minus I2 opposite direction. Next current entering here. So it is plus 10. Okay. So one loop equation. Same another loop equation here. Current is leaving because it will go up. So minus 10 I2 then I1. I2 minus I1. Previously in that loop I1 minus I2. But here this is the reference point. So I2 minus I1 it will come. So it is then I2 minus I1 then plus current enters here. So 6 I2 then plus 4 I2. So we got two equations I1 and I2 and we can solve the by elimination technique or Cramer's rule, up to you. So like this you have to solve the equation. If the big circuit is given, it will take some time. So if you solve this, you will get the result like this. Okay, what is a method to for the mesh analysis? For mesh analysis, identify mesh in the circuit. Which meshes are there? You have to identify. Assign the currents to each mesh. First I1, then I2, and then write KVL, Kirchhoff's voltage equation. This is the voltage as it is, no problem. This here KVL means voltage. 5 multiplied by I1, it becomes voltage. So voltage equation you have to write. So next, solve the simultaneous equation. Find the mesh currents. So like this. Then what is the node analysis? Identify nodes in the circuit. In the circuit, what are the nodes? Assign voltages to the other nodes. Okay. Assign the V1, V2, assign it. Next, write the KCL equation for each node except the reference node. Leave the reference node and write the Kirchhoff's current equations for each node. Solve the simultaneous equation to find the node voltages. So, okay, what is the question? Check. Okay, sum of voltage drops equal to sum of current rises in Kirchhoff's voltage law. Is it true or false? On the left hand, what is Kirchhoff's? Okay, on the left side, Kirchhoff's voltage law. What it actually tells? Voltage law. Voltage law means sum of all the voltages equal to 0, right? And in that, so on the left hand side and right hand side, if you want to write, what it will take? Voltages rise is equal to voltages down, or sum of the source voltages equal to sum of the passive voltages, you can say. But here you just observe here, sum of voltage drops is telling. Okay, up to here it's related to voltage related, no problem. Then here sum of current rises. Current is related to the Kirchhoff's voltage law? No. So like this, first what verify what's is it related to that or not. On left hand side it's related, right hand side not related. So forget about the law. It's not related itself. So it's a false. Okay. So it's false. Now find the I0 in the circuit. So I0 is here, and here 2 amps current is flowing towards inside to the node. 4 amps current also flowing inside the node. 10 amps is coming out from the node, and this I0 is coming out from the node. So what is the general equation? Number of the summation of the currents entering is equal to summation of the currents leaving. So on the left hand side, let us take summation of the current entering. What are the entering? 2 and 4 are entering. So 2 plus 4, it is 8, equal to current leaving 10 plus I0. Right? On the left hand side, 2 plus 4 is 6, and on the right hand side 10 plus I0. So find the I0. So push the 10 on the other side, it will become minus 10. So minus 10 plus 6, it is minus 4. So what it means here, it should enter this one. It's showing that what the direction is wrong, but we don't care about that. We need the correct answer only. So the correct answer is minus 4. So the correct answer is minus 4 ampere. Okay. A network has 12 branches. B is branches. 8 independent loops. L is loops. 8. How many nodes are there in the network? What is the equation I told you? Branches equal to number of nodes plus number of loops minus 1. So what we need here? Loops we need, right? No, we need nodes we need. So nodes is equal to number of branches plus 1 minus number of loops. So branches 12 plus 1, 14 minus 8. How many? 7, right? 5, correct, 5. So the answer is 5. Okay, which of the circuit in the figure, this is like this very important one. Which of the circuit in the figure will give VAB as 7 volts? Resultant voltage in the two terminals should be 7 volts, which it will give. Okay, first one. In this branch A and B, that means in terminal A and B, the result should come 7 volts, positive 7 volts. Now, take the loop equation. Generally, what we need for voltage, KVL, Kirchhoff's voltage law. So, we need a loop equation, right? Form a loop from down to up, no problem. Up to you, up to down, down to up to you, no problem. So, current leaving from this 1 volt, okay? So, minus 1. Current leaving from this 3 volts, how much? Minus 3. So, minus 1, minus 3, minus 4. Current entering this source, plus 5. So, it is minus 4 plus 5 plus 1. Result is coming? No. So, first figure is no. Second one, current is leaving minus 1. Current is leaving minus 3. Current is leaving minus 5. So, 3 plus 1, 4 plus 5, 9 volts. Minus 9 volts. This is also not correct. So, current is now entering plus 1. Current is leaving minus 3. Current is entering plus 5. Okay. So, where is the plus? Yeah, 5 plus 1. 6 minus 3. This is also not correct. Now, last one check. Now, current is entering plus 1. Current is leaving entering plus 1. Current is leaving plus 1 minus 3. And current is leaving how much? Plus 5. So, leaving minus 5, sorry. Minus 5 minus 3. How much? 8. Plus 1, 7. You are getting answer 7, right? Positive, negative, there is different issue. Okay. Resultant 7 volts is coming because as per our direction, what you assume, that is important. Okay. If you assume direction reverse, it is plus 7 volts. We assume down to up. If you assume down, up to down, it is positive 7. So like this, we have to get the answer as a D is the answer. Now, in the figure, what is the current I1? So just we have to write the mesh equations and find the I1 loop equations. So that's you can do it. The answer I think 2.476 I think for this answer. What is I1 and what is I2? We can find with the mesh analysis. Okay, the current through a branch in a linear network is 2 amperes. 2 ampere is the current. When the voltage source is 10, V is equal to 10, I is 2. I, V, we got it. Now, if the voltage is reduced to 5 volts, from 10 to it is half. It is reduced to 5 volts. The voltage becoming half. Now, and the polarity is reverse. A voltage, the source polarity also reverse. It becoming 5 and means becoming half and polarity is reversed. So, then the current through the branch will be polarity is reverse and the current through the branch will be. Now, first Ohm's law. What is Ohm's law? V is equal to IR. Right? If the voltage is half, what is the relation with the current? Linear. It will be half. Okay. Now, what we now he is telling that the polarity is reversed. Right? So, now polarity reverse means current also will reverse. So, what the resultant will come? Negative. Previously it was positive, now the result will come negative because polarity is reversed. Now what is asking? The current through the branch. So, yeah, now when the voltage is half from 10 volts to 5 volts, that is half, the current what it will be? Half also. Previously the current is 2 amperes. Now the current will be half, means 1 ampere. Now how the polarity? Reverse. So what is the resultant? Minus 1. Okay. So this is the result. Minus 1. So answer is A, minus 1. Okay, circuit has two meshes like this. We have, yeah, like this 2 meshes we have. Okay, mesh 1 contains 12 volt source. Mesh 1 contains 12 volt source. Source and is 6 ohms resistance. How it will be? Like this. A 12 volt source and a series resistance of 6 ohms. 12 volts and 6 ohms, like this it will be there. If you draw, we can easy for you. Okay, now and a 8 ohm resistors, mesh 2, sorry. Mesh 2 contains 8 ohm resistor and shares 6 ohm resistor. See, mesh 2 contains two resistances. One is 8 ohms and one is 6 ohms. But he is clearly telling that which one is sharing with the mesh 1. So, which one is sharing? 8 ohms and 6 ohms means middle. In the middle, 6 ohms is there. Right? On the right hand side, 8 ohms is there. So, 8 ohms is separate and 6 ohms is separate. Oh, okay. This middle one, 6 ohms is shareable. Now, with mesh 1. What is the mutual term in the mesh equation? What is the mutual term in the mesh equation? Which is a mutual? 6 ohms is a mutual. What is the equation for that? 6I2, 6I1 minus I2, 6I1 I2 or 6I1? What is the mutual term voltage? Which is sharing 6 ohms. In that 6 ohms, as per the mesh analysis, what is the equation? In the 6 ohms, it is 6 multiplied by the first current minus the second current. So, this is the equation. 6 times I1 minus I2. Or 6 times I2 minus I1 also correct. Both are correct. Okay, because if you see from the mesh 1, it is 6 times I1 minus I2. If you see from the mesh 2, it is 6 times I2 minus I1. So, both are correct. But here only one is given, so this is the correct answer.
But since the voltage source is in the
Left hand side, so it is not included. It is not common.
correct?
I1 minus I2, but loop analysis or mesh analysis always
The voltage source does not matter.
that doesn't matter. We have to check the which is the reference point, first mesh or second mesh. There is the reference point. Okay, if a planar circuit has 6 branches and 4 nodes. How many independent mesh equations and node equations are required respectively? Okay, I told you mesh equations means number of loops equal to number of meshes, and node equations will be 1 minus. How many node equations I told you? One reference node we have to leave it. Right? If you have 3 nodes, then how many node equations will come? Only 2, because one is reference node. But in mesh, loops are, let us take 3 loops are there. How many loop equations will come? 3 loop equations. This is the blind rule. Okay, for mesh, no disturbance. How many loops, how many mesh, that many equations. But for nodes, writing the node equations, 1 minus. Because one will take as a reference. That's why. So as for this, we have how many 6 branches, then 4 nodes. Okay, here branches and nodes is given, loops not given. So first we have to find loops how many. Right? What is the equation? Branches equal to number of nodes plus number of loops minus 1. Okay, so loops is equal to branches minus nodes minus plus 1. So branches how many? 6 plus 1, 7 minus nodes 4. 7 minus 4, 3. So how many loops? 3 loops. So how many loop equations? 3. If number of nodes are 4, how many node equations? 3. So because minus 1. So 4 minus 1, 3. So 3 loops and 3 nodes. Equations, not nodes, node equations we are telling. So which one it is? Yeah, 3 mesh and 3 nodes equations we need. So answer is C, B. 3 mesh and 3 nodes. And this is also B, this one. This is A, minus 1 ampere. This is C, that is 2.476. And this is D, this is the correct one. And here I think A, yeah, 5 ohms. Yeah, 5 is the number of nodes. And here is a B, minus 4 amperes here, and false. So like this, we have another 2 question slides, then we'll finish it. Now come to the capacitance, inductance, and their equations. What is capacitance? It is a parallel plate capacitance we have. This its equation is based upon its voltage and charge accumulated on the plates. So what are the 3 like Ohm's law, what are the 3 terms here? We have Q, we have V, and we have C, capacitance, these 3 terms. Okay. Now, as per the structure, so this is the definition, we can see it. As per the structure, the equation like resistance equal to rho L by A. But here, as per the structure of the capacitor, C is nothing but their rho is there, here epsilon naught are there. This is called permittivity, and multiply by area, and is a distance between the plates. Distance between the plates. Their length divided by area is there in resistor. Okay. Here area is on the top and distance, the length, their length is there. Here between the distance is reversed. So how it behaves as per the capacitance value in resistance and capacitance? Exact opposite. Okay. More area, more capacitance. There in resistance, more area, less resistance. Okay. So like this it is there. So you means cross verification, if you know, it is easy to remember how the capacitance and how the resistance is there. Okay, where C is the capacitance, all are there. Permittivity for medium and permittivity of the material, that is okay. These values will be given, x naught r and x naught r always given if we ask the value of the capacitor. Now, in terms of the, as per the Ohm's law, for the resistance, we have here another equation based upon the C, V and Q. Capacitance C is equal to charge accumulated divided by the voltage. This you have to remember. C is equal to Q by V. Or amount of charge stored is nothing but capacitance multiplied by voltage applied to the capacitor. Just ZERP. This you have to remember. Q is equal to C times V. Now, what is the, how the capacitor will behaves if these are in series? Yes, I told you how the resistance and capacitance as per the structure opposite. So how the resistance and capacitance as per the series and parallel combination opposite, right? So same. If this is series 1 by C1, 1 by C2. In resistor it is in parallel. So like this. In parallel it is C1 plus C2 plus C3. So now coming to the inductance. Inductance is, what is inductance? It is a loop of wire. Nothing but. The Jama is called inductance. So here the turns, we call it as turns. Number of turns we call, and the length of that turn, not the length of the wire here. Length of the turns after it is formed. So it is a length. Now cross section area of the medium. This medium is called core. The core on which the wire is turned. It's called, you have to take the cross section area. And that cross section area of the medium may be iron core or maybe the air core, depends. And number of the turns is capital N. So the value is nothing but, like C, we have value L is equal to, this is your permeability, this is permittivity. Permeability times N square A divided by L. Okay. Here also the inductance will depends upon the area of the core. Area of the core on which it is have the turns, and length of this one. Length that the turns is made. So this is your inductance. Now okay. Now come to here. Inductor is given by V is equal to L di by dt. Here rate of change of current multiplied by the inductance is nothing but your voltage you will get. That's your voltage. Here also voltage you are finding. If you find the current, if you want, you have to take L in this side 1 by L, integral with dV by dt it will come. Integral dV. Integration of the voltage will get it for getting the current. Okay, it is like quite opposite. Capacitance and inductance is quite opposite, and it is same like a resistance L1 plus L2 plus L2 in series, and inductance is parallel 1 by L1 plus 1 by L2 plus L3, like this it will come. Okay, now we have to see the energy also, because in resistance we see the power, but here we have to see the energy. Okay, because energy, the elements capacitance, inductance always referred as for the energy storing elements. Resistance, energy dissipating energy element. So power multiplied by time, directly it will come. VI time multiplied by time in resistance, how much energy dissipated it will come. But in inductance it is slightly different. So E is equal to half CV square and E is equal to half Li square. Generally you remember capacitance means charge. Charge means voltage. Inductance means magnetic field. Magnetic field means here current. So inductance always go with the current, capacitance go with the voltage. So half CV square, half Li square. Remaining are same. Half CV, half C, half L. Both are same. If capacitance, half C. Inductance, half L. The multiplication factor is based upon its quality. Means energy. Energy is based upon voltage. Inductance, energy based upon current. So here V square, here I square. So like this you have to remember. Capacitance always deals with the voltage. Inductance always deals with the current. So half CV square, half Li square. Coming to the problems. Okay, if the inductance is doubled while the current remains constant, the stored energy becomes. Now it's very, very important. Inductance is doubled while the current remains constant. What is the equation of the half? Is asking energy? Yeah, half Li square. Li square. Inductance is doubled. Current is constant. I is constant. Half Li square. Inductance is doubled. So inductance doubled. What about the current?
Remains constant.
Constant. So what is the
energy is double.
energy is doubled. Okay. But another question will come where the equation we have to make changes. We'll see that one. Okay, if the current through a 10 millihenry inductor increases from 0 to 2 amperes, how much energy is stored in the inductor? So energy is half Li square, right? So it is current through the 10 Li square. So L is there, 10 milli, I is there, 2, I square, right? 2 multiplied by 2 and multiply half, taqsim half. So 1 or 2 will cancel and 2 multiplied by 10. So it is 20 millijoules. Energy always in the joules. So it is 20 millijoules is the answer. Now inductors in parallel can be combined just like resistors in parallel. True or false? Capacitors and resistors are quite opposite, I told, while they're joining in the series or parallel. Inductor and resistors are same. So inductors in parallel can be combined like resistors in parallel because both are have same rules for adding and parallel, right? So it is true. Both are same. Next. When the total charge in a capacitor is half, the energy stored, not capacitor, half CV square. But what is the question is there? What he is asking?
The
Charge. But in energy, what it is there? Half CV square. C is the capacitance, V is the voltage. There is no charge in that, right? So what we have to do? Rearrange the equation. So half C is there. Now voltage we can rearrange. Voltage we can rearrange in terms of charge. What is the charge is equal to C times V. Now charge stored in the capacitance is nothing but C times V. So substitute there here in this equation half CV square where we are replacing voltage with the charge. So what is the voltage? Charge is equal to CV. What is the voltage?
Q over C.
Q taqsim C. So substitute here. Here V square is there. So Q square divided by C square. So half C multiplied by Q square by C square. So C will cancel once. So Q square will be there. So what is it telling? When the total charge of the capacitor is half, the energy stored. Now, oh here total charge. Yeah, charge you have to make it half. So Q square. Q square is there. Now we got it energy equation in terms of Q and C is nothing but half half C times Q square. C times Q square. It is half CV square, but rearrange that V in terms of Q, then it is half C times Q square. So Q, how much it is changing? Charge is now half. Means nus it is changing. So square of the nus 1 by 4. So 4 times it is decreasing now. 1/4. 1/4 we can say. Remain same is 1/4, double or quadruple. Quadruple means 4 times. And if it is 1/4 means 1 by 4. Right? So this is the answer. So Q square is coming here. So charge is half, then energy will be 1 by 4 square.
So it means that the formula for the capacitor applied to the energy formula.
Yes, we have to rearrange. Capacitor equation and energy equation. Capacitor equation is Q is equal to CV. Rearrange it and substitute here. Because as per the question, you have to rearrange it. Yeah. When a capacitor C is connected to a constant DC voltage source V, the charge Q stored is. The charge Q stored is. What is the equation? Q is equal to V by C, Q is equal to CV, Q is equal to 1 by CV square, Q is equal to half V square by C. Same. You have to rearrange it and you have to write the equation here. So in terms of when the capacitor C is connected to a constant DC voltage source V, then Q energy, the charge Q stored is Q is equal to generally what is it is C and V. So this is the equation directly. Okay. So if you ask energy, then we can rearrange it. What is energy? That one we can rearrange, but directly we have Q is equal to CV. Okay, if the capacitance of a capacitor is doubled, now capacitance of a capacitor C is now doubled. While the charge remains constant, the energy stored is, what is the equation? Half CV square. Okay, so what we are increasing now? Capacitor is value is increasing. Now what is the energy? Half CV square, direct equation, no need to rearrange it. Half CV square. So what is it changing here? Capacitance is changing, right? The capacitance is double. So C is double, not there is no square, just C. When it is 2 times, energy will be 2 times. So it is double or half double. C is the answer. Okay, last question. Two capacitors C1 and C2 are connected in series. The charge on each capacitor is, this is very important, which is not there in the formulas. Resistance. When resistance is there in series, which one is divided there? Voltage or current? When two resistors are in series, which is dividing? Voltage is dividing or current is dividing?
Current is the same.
Current is the same, voltage is dividing. Okay. I told you it is opposite in the capacitance. So here in capacitance, what is telling? If the two capacitors C1 and C2 are connected in series, the charge on each capacitor will be same. Because in series, voltage will divide, right? Voltage will divide. But if you come to the capacitor, the current will divide. So capacitance will be, the charge will be the same. So because the voltage applied, series equation, C1 plus C2, this is not valid. Series capacitance, which is the equation? 1 by C1 plus 1 by C2. So voltage will be same. So voltage is same means charge is same. Okay, directly proportional. So it is the value is the same. So these are the answers what we discussed. Okay, last slide we can go. Okay, here now we go. Oh yeah, last 2 slides. Thevenin's theorem, Norton's theorem is there. Okay, I will not go to the Thevenin's Norton's in deep. Just remember that Thevenin's generally resistance we will find how. Just remove that load resistance from the big circuit where we want the Thevenin's value or load resistance where we want it the analysis. Remove that resistance. See from that end, get the equivalent resistance. From the generally the load resistance will be on the right hand side. Then remove that one and see from that terminals. From the left hand side, solve the equation, solve the circuit, series, parallel, like this. Then you will get one equivalent resistance. That is called Thevenin's resistance. And it is equal to same Norton's also. Procedure is same. For Thevenin's and Norton's, finding equivalent resistance is same. So Thevenin's resistance is equal to Norton's resistance. That you have to remember. How to find? I told you. Just remove that load resistance and see from that side. That is on the generally on the right side. And solve the equation from the, solve the circuit from the left hand side. Series, parallel, remove it, and one equivalent resistance will come. So this is one. Now how to find the voltage? Remove that load resistance. Remove that load resistance. Check the voltage across these two terminals. Open circuit terminals. What is the voltage? Put the mesh analysis, put the node analysis, then find the voltage across these two terminals. That is the VThevenin's. Generally, that much big they won't give. Small questions they will give. We will see that. For Norton's, we have to short those open circuit terminals and find the current. So we have some equations, some problems there. Yeah, first one. In a linear circuit, superposition, yeah, superposition also there. What is superposition? If let's take in a circuit, many sources are there, maybe current or maybe voltage. Finding resultant current in each branch and finding the voltage in each branch is very difficult by using the mesh analysis, node analysis. So what superposition theorem tells me is just remove the other sources, keep only one source. Other source removing means is how? Means we have to remove the current source, make it open circuit. Remove the voltage source, make that branch short circuit. Like that one. No need to any further simplification. Just remove the voltage source and make short circuit. Remove the current source, make open circuit at that time. Now see the complete circuit with only one voltage source, what you assumed. Okay. Then solve the complete branches of resistance becoming equivalent resistance. Then voltage divided by that resistance, we will get the current. Now come back to the different branches. What is the current and what is the voltage? One circuit is finished. Second circuit, take the another source and remove the other sources. Like this, if we have n number of sources at a time, one source will be acting. Simplify it. Now the current in that branch, a particular branch, is nothing but sum of the individual currents what we find during removing and adding. Okay, so that is superposition. So what it's telling, in a linear circuit, superposition theorem states that the total response is the sum of individual responses caused by each independent source acting alone. Correct or wrong? It's correct, because sum of the individual responses means at a time it is considering one source only, not more. Acting alone means one source is acting there. Remaining we are forgetting. So the sum at the end of this all is the superposition. Correct. This is true. The superposition principle applies to power calculation. True or false? What I explained about superposition, why we use superposition? Where many source voltages or many sources are there, we will use only one source at a time and we will find voltage, we will find current. Did I mention any power there? No. So this one is false. The Norton's resistance Rn is exactly equal to the Thevenin's resistance. I already told you. Procedure is same for both Norton's and Thevenin's finding. So once you find Thevenin's, it is equal to Norton's resistance. True. Okay, a circuit has two sources, 10 volts voltage source in series with 5 ohms. 10 and 5 ohms are in series, that is voltage source and resistance. And a 2 amps current source in parallel with 10 ohm resistance. Both feed the same load. Using the superposition, what is the load? Current of the load 10 ohms. So here, all are in sentence is there. When circuit is there, easy to analyze. But when sentence is there, first you have to create a circuit as per that, then analyze it. So it is very difficult. So be careful to understand the sentence first. So what is that? A circuit has two sources. First is 10 volts, another 2 amps. Right? Okay. 10 volt source in series with, one is 10 volt source with series with a 5 ohm resistance. And 2 amps current source in parallel with 10 ohms. Okay. Both feed the same load. So on the right, the same load. On the right hand side, there is a load which is same load. Using the superposition, what is the load current if the load is 10 ohms? On the right hand side, there is a load resistance on the right hand side. Before the 10 ohms resistance, which is the load resistance, there is a 10 ohms resistor again and 2 ohms current. 2 amperes current. So these two are in parallel. 10 ohms and 2 amperes are in parallel. With this parallel, a series circuit is there with 10 volt source and a 5 ohms resistance. This is in series. So one is in series, voltage and resistance, current source and resistance is in parallel, and there is a load resistance. So like this, we have complete circuit. Then only we can start the analyzing. What we have to analyze? By using superposition, what is the current in the load 10 ohms resistance. So it is a big process. If you want, you can do it, or you can do it later, no problem. Just once you find the circuit, it is easy. Another method is there here, it's called source transformation method. What is source transformation method? Is nothing but just a voltage source in series, a resistance can be converted to a current source with a parallel resistance, vice versa. A current source with a resistance in parallel can be converted into a voltage source in series with a resistance. How? In this equation, we know that 2 amps current and 10 ohms resistance are in parallel. So, this can be converted into voltage source. How? Just V is equal to IR. 2 multiplied by 10. How much? 20. It becomes as a voltage source. And how it will be in series with a 10 ohms resistance. So, this will be the 10 ohms resistance in series with the 20 volts voltage source. Already we have a 10 volts voltage source and 5 ohms in series, right? So 10 volts and this is 20 volts. How much?
30 volts.
30 volts. We got the resultant voltage source. Next we got the 5 ohms and here 10 ohms. How much? 15 ohms is the resultant, right? So 15 ohms we got it. 15 ohms total resistance and total voltage 30 volts. Now what is the load resistance? 10 ohms, which are coming in series. So 15 plus 10, how much? 25. And this one, voltage source, how much? 30. So 30 divided by 25 is your current. So 30 divided by 25, almost 1 ampere, more than 1 ampere it will come. Okay. So this is a Thevenin equivalent circuit has V Thevenin 24 volts and R Thevenin 6 ohms. What is the Norton's current? See here, Thevenin's is there, you are asking about Norton's. Same source transformation. If a voltage is there, resistance is there, directly you can find IN, which is nothing but V Thevenin's divided by 6. That is R Thevenin's. Because R Thevenin is equal to Rn. So V Thevenin's divided by the Rn is nothing but your IN. So 24 divided by 6. Yes, 4B is the answer. Okay, next. A circuit has 12 volt source in series with 4 ohms resistor connected to a load resistance RL. Now 12 volt source is there, 4 ohms resistance is there, and load resistance also there. Means 3 items are there here. Okay. Now another branch 6 volt source in series with 2 ohms resistor also connected to RL. So on the left hand side one circuit is there, on the right hand side another circuit is there. So what is telling? 12 volts voltage source with 4 ohms. 12 volts and 4 ohms in series, and there is a load resistance in parallel. Next, 6 volts source in series with 2 ohms resistor also connected RL. On the right hand side, 6 volts source in series with 2 ohms. Means 2 voltage source and 2 resistances are there. In between, load resistance is there, right? So what you need? What is the Thevenin's equivalent resistance by RL? So what I told you how to check the resistance, just remove the RL and see from the terminal inside so that we can get the equivalent. Now on the left hand side, what are there? One voltage source is there, one resistance is there. So voltage source, what we have to do? We have to make short. If current is there, we have to make open. So this voltage source, which one? 12 volts on the left hand side, which is making short, and only 4 ohms will come. On the left hand side 4 ohms will come, and on the right hand side we have 6 volts which becoming short, and in series 2 ohms becoming 2 ohms resistance. So this 4 ohms and these 2 ohms will become now parallel. From seeing from this point, this 4 and 2 becoming parallel. So make it the parallel, that is nothing but your Thevenin's resistance. So okay, that 4 and 2 will parallel will be how much? 4 plus 2, 6. 6 divided, 4 into 2, 8. 8 divided by 6, 1.33. Okay, so this is okay. These are the answers, 1.33. Okay, next, last one. Yeah, AC, which you didn't concentrate in your studies. I know only DC you studied at the time of what we call graduation level 3 subject. AC is very important here. So generally V is given in Vm sine omega t plus phi. This is called instantaneous voltage or current equation. If it is V, it is voltage. If it is I, it is current. So Vm is a magnitude of the voltage or maximum value of the voltage up to where it is going from 0 to the maximum Vm. Then coming back to 0. Then coming back to negative maximum. Then go to the 0. This is sinusoidal, sine wave. Okay. Now sine, if it is a sine, where it will start from 0. If it is cos, when it will start from 90 degrees. Okay, half Vm, start from the Vm to the 0, again minus Vm like this. Okay, now omega t plus phi. Omega t is nothing but your time period. Omega generally in radians per second, and is the time is the seconds, omega t. So plus phi. Phi always is how much it is lagging or leading generally. Generally, if resistance is there, how many items will include in the resistance? Voltage and current. Together is power, right? Both will act together only. Only current won't be there in the resistance, or only voltage won't be there in the resistance. All three together only Ohm's law, right? So, as per that, if there is a voltage, if there must be a current also. When voltage is there, current also be there. Now, when the voltage is starting from one point, how the current will start from that point? It is same point it is starting, or it is shifting somewhere. So that is called your phase angle. In phase. In phase means both are starting at the same point. It is called in phase. For resistance, there is no delay. There is no integration. There is no derivation. For integration and derivation only, the sign will change. Sine will go to the cos, cos will go to the sine, right? If there is integration and derivation. So nothing is there for the resistance. So it is in phase. For resistance, there won't be any lagging or leading. The phi will be 0 for voltage and current. The phi will be 0. This is called in phase. For inductance. Inductance, the current always lag. Means if the voltage starting at 0 point, the current will start after the 90 degrees. Means some lag. If it is pure inductance, 90 degrees must. Generally in the market, nothing is pure, right? Inductance will have with resistance. Capacitance will have with resistance. So angle will change. 90 degrees not there. It may be 45 degrees, maybe 80 degrees, depends upon its purity. So the lagging always there. The current always lag the voltage, means it will start delay. The current delay the voltage for the inductance. Okay, it's quite opposite. The current will lead the voltage for the capacitance. The current will start first, then voltage. Or we can say voltage lags the current. In inductance, current comes later than the voltage. In the capacitance, voltage comes later than the current. So quite opposite, lagging, leading. We have to check. Okay. Here Xc, if we have capacitance, the equation we have to, is given by 1 by 2 pi Fc. If we have inductance, we have 2 pi Fl, where F is the frequency. What is frequency? Number of cycles per second. Means what is the cycle? From 0 to 90, again 0 to minus a maximum, again 0. It's called one cycle. Positive and negative together is one cycle. So in 1 second, how many cycles is nothing but your frequency. So that is given by XL is 2 pi Fl. Here pi is, you have to use 3.14, not 180 degrees, because I told you here radians, omega is 2 pi f. Here omega is nothing but 2 pi f. Yes, where here f pi you have to take is 3.142 you have to take, not 180 degrees. Generally 180 degrees, it is in degrees, right? So degrees always go within the sinusoid. When you come into the polar form or complex form, then we have to use pi as a radians per second, that is 3.142, not in the degrees. Complex term it is. Same, Xc is 1 by 2 pi Fc and XL is 2 pi Fl. Just we have to remember this. Okay, now coming to the, Xc, XL we know. Okay, relation. See, if it is Vm cos omega t plus phi, the phasor domain is nothing but it's phi only we have to write. Vm is the maximum value and the angle, how much it is lagging or leading. That only you have to write. Phase angle is called. Okay. Now Vm sine. Why it is 5 minus 90? Generally, sinusoid in voltage or current taken with the cosine, not with the sine. Cosine, cos term, cosine term. If it is in sine term, just we have to first convert into cosine, then start transforming into the time domain to phasor domain. You have to transform from time domain to phasor domain. First verify in which position they are there. Is it in cosine form or in sine form? If it is in sine form, convert it into cos, then transform easily. One step. By seeing itself, we can transform, not a big deal. So, by seeing itself, cos omega t plus phi in the phasor domain is nothing but Vm at an angle phi, as it is. This is a polar form, right? You can convert it into rectangular form, a plus jb. You can convert with the rectangular form, a plus jb. Now, it is Vm sine omega t plus phi. Now, here sine is there. First one, where do we have to find? Convert to cos. So, when converting to sine to cos, sine theta equal to dash in terms of cos. Anyone? Sine theta equal to dash in terms of cos theta. Sine theta is equal to cos theta minus 90. Okay, that's why here see 5 minus 90 is coming. Because I am converting the sine into cos. Then I am changing to the phasor domain. So sine theta is converted to is cos is nothing but 5 minus 90. Thus minus 90 you remember. Now same here I. Here V is there, I is there. Both are same. Cos omega t plus theta, it is I theta. If it is sine, it is theta minus 90. Remaining is same. Now, if we have R, L and C, what is the relation in the phasor and the what we call a time domain? So first time domain, V is equal to Ohm's law. V is equal to IR. No changes because both are in phase. Voltage and current are both are in phase. No integration, no derivation. But L, when inductance is there, L di by dt. You must derivate it. V is equal to L di by dt. When C, capacitance is there, I is nothing but C dV by dt. I told you, capacitance always related with what? Voltage. Inductance always related with what? Current. So, for inductance, we find related with the current, di by dt. Because it's change in the current only, it will give the result. Change in the current only, it will give the proper result. But in capacitance, change in the voltage only, it will give the proper result. So, that's why this is the relation in time domain. Now, always analyze with phasor domain only. First, check the time domain, convert it to phasors, that is complex variables, then solve it. V is equal to IRI. Same, Ohm's law, no change. Here, L can be changed to 2 pi FL. This is XL. That is called J omega L we call. That is 2 pi F is nothing but omega. 2 pi F, what is 2 pi F? It is omega. So radians in second. So it is J omega L times I. Now here, C dV by dt. C is nothing but here. 1 by 2 pi FC. 2 pi F is nothing but omega. 1 by omega C. So 1 by J omega C. That is I. I is multiplication. So like this, time to frequency domain, we have to transfer it. So, okay, now if Vs is 10 cos 4t is given. That is how the phasor as per this, how we can form into the phasor? Vs, Vm 10 as it is. Angle, is there angle here? No, so 0. So 10 at an angle 0 degrees. First we got in the phasor voltage source. Now resistance in the time domain and the phasor domain, same, no changes. 5 ohms means 5 ohms only. But capacitance, it is in time domain, 0.1 farads. Now, what is in the phasor domain? It is 1 by 2 pi fc. What is 2 pi fc? What is 2 pi f? Omega. What is omega here? 4. Omega is 4, right? That is equivalent to 2 pi f. So, here 4 times c. So, 1 by 4 times c. That is 1 by j omega is 4 times c, 0.1 farads. So, this is your resultant. So, what is z? This z is nothing but summation of this. 5 plus this one. 5 plus 1 by j omega c. So, 5 plus 1 by j 4 times 0.1 and you just rearrange, make it on the top, above side, it becomes 5 minus j 2.5 will come z. So, total impedance we got it here. That's called impedance. When there is a real part and imaginary part together, it is called impedance. In the real part, resistance will be there always. In imaginary part, inductance will be there and capacitance will be there. Depends. If inductance is there, positive. If capacitance is there, negative will come. So here, negative is coming. So by seeing the equation, we can say which type of circuit it is. If I say 10 minus J5, which type of circuit it is? Capacitive circuit with a resistance. If it is a 5 plus J10, which type of circuit is? Inductive circuit, because it's a plus J. So like this we can find. So now finding the current, I is equal to V divided by Z. So what is V? 10 at an angle 0 degrees. Z is 5 minus J 2.5. The problem is here. Okay, we need I. So V divided by Z. So V how much? 10 at an angle 0 divided by 5 minus J 2.5. But V is in polar form. Z is in rectangular form, right? Both solvation. Okay, calculators are there nowadays. Directly we give it will give the result. But what is the procedure is? For division, both should be in polar form. For multiplication, both should be in the rectangular form. Okay. For addition and multiplication, for both should be in the rectangular form, A plus JB, like this. For division, both should be in the polar form. It is easy. How? Polar form in the top and polar form in the down. A by B, automatic division. And angle theta 1 minus, it will go up theta 2. That is the angle. The angle go when up, it become minus. So polar form for division, remaining all rectangular form. So here this rectangular form can be converted to polar and divide 10 at an angle 0 with this one. Then you will get the answer 4.47 at an angle minus 63. So like questions, last slide. So in figure, V is cos 3t and I is sin 3t. The element is. Now you tell me. How can you find? V is question in the question. V is cos 3t and I is sin 3t. The element is. How can we find the element resistance? Inductance or capacitance or resistance? If it is a resistance, both should be same. Cos cos. Both should be sin sin. Then it is a resistance. But if it is one is cos and one is sin, then we have to see its angle plus phi or minus phi. How? By default, in which form sinusoid should be there? Cos form. So which is the cos form? V. Okay, this is the reference point we got. V is equal to cos 3t something we got. Now I is in sin, so this is not acceptable. We have to first convert it into cos. So convert this into cos. How it will be? Cos 3t minus 90 degrees. So minus 90 degrees means what? Later than, means negative 90 degrees. Means it will start 90 degrees after. So the voltage is starting at 0 degrees. Current is starting after 90 degrees. So current is late. So which form it is? Inductance or capacitance? Inductance. Current lags the voltage is inductance. Current starts later than the voltage is the inductance. Current start before the voltage, it is a capacitance. So this is an inductance. So this element is nothing but your inductor and inductor B. So like this typical questions will ask. So you must know what exactly what it knows. Okay, if V1 is equal to 30 sin omega t plus 80 degrees, V2 is equal to 20 sin omega t plus 30 degrees. Which of these statements are correct? V1 leads the V2, V2 leads the V1. First, what I told you, both should be in the same form and that should be in the cos form, right? So first one is cos form, no. Second one is sin form, right? Okay, both in the same form, sin, it's okay, no problem. Because we are only finding which is lagging, leading, so not a big deal. So what is this here? Sin omega t plus 80 means it's after 80 degrees. Now it is plus 30. Which is starting first? Plus 30 is starting first or plus 30 plus 80 is starting first?
Plus 30. Then it's plus 80.
Plus means what? Means before. Minus means what? Delay. Yes? Plus means before, means previous. Minus means after. So here plus is there. Both are plus. Okay. Again, good question. Both are plus. But which is having more plus? 80. Which is having less plus? 30. So 30 will start first or 80 will start first? 80 will start first. So which one is? V1 leads the V2. 80 degrees before it's starting. If it is minus, it's starting later. So like this. Okay, a current source in a linear circuit is I1 15 cos 150 pi t plus 50 degrees ampere. Find the frequency. Frequency, how will you find? This form. Cos omega t, sin omega t, omega. What is omega? 2 pi f, I told you, right? So how much here? 150 pi. 2 pi f is equal to 150 pi. Find the f.
Divided by 2, 75.
How much? 75. The correct answer is 75 hertz. Okay, 2 pi f is equal to 150 pi. So pi will cancel. 150 by 2 is 75. So next, transform the following sinusoid to phasor. Now 20 sine 4t plus 135. Directly by seeing itself we can transform, I told you. So the first element is nothing but Vm. How much? 20. The next what we have to see? At an angle phi. What is the angle here? Phi 135. So if I write 20 at an angle 135, is the correct answer? Is the correct answer or wrong?
No, because it's in sine.
Because it is in sine term. We have to first convert it into cosine, cos. So sine in terms of cos, if you convert minus 90, we have to add. So it is 20 at an angle 135 minus 90. So how much it is? 45. So 20 at an angle 45 is your correct answer. 20 at an angle 45 is your correct answer. So tricky questions will be there. Directly I told you, oh, directly we can answer it. No, something is there inside. You have to just cross check. If the voltage signals V1, voltage signal is V1 minus 10 cos 188.5 t plus 50 degrees, the angular frequency omega is, how the equation, sine or cos omega t plus phi. Angular frequency is omega t. What is the angular frequency? 188.5. Now, okay, 188.5 is good. Now see the answers. Which is 50? Okay, absolute. There are two answers are there with 50. Those are not there. Only two answers are there with 188.5. So which one is correct?
Per second, because it's angular.
Angular means always in radians per second, right? So it is a omega always in radians per second, 188.5. Okay. A sinusoid, a sinusoid current is usually referred as positive current, negative current, alternating current, or direct current. Sinusoid means maybe sine or maybe a cos. So it is referred as a positive current or a negative current, AC current or a DC current.
Alternating current?
Seeing only we can say. Alternating only. Sine. What is sine wave? Alternate. My name itself is telling, right? Maybe cos or sine. It is alternate only, right? It's not direct. It's not constant current. So answer is alternating current. Okay. In AC circuit analysis, if the given circuit is in time domain, then the following step is needed as a first step. If the given circuit is in the time domain what? Sin omega t, cos omega t. This is in time domain. Okay. So for analyzing, but first what we have to do, I told you, first transform it to phasor. Transform sinusoid to phasor. First term. If it is already in phasor, no need to transform. Already is in phasor, we can start the analysis. Okay. So the last question. The real part of the impedance is called. I told you there is a real part and there is an imaginary part. In imaginary part, two things will be there. One is, if it is positive, it is a inductance. If it is negative, it is a capacitance. The remaining is real part is a resistance. The real part always resistance. Imaginary part we have two options. Okay, inductive reactance or capacitive reactance, like this. Okay, so resistance. So these are the answers what we have. Okay, some more questions are there. You can, these are slides already circulated to you previous the PDF answers also there. You can see it. Okay, any doubts? F4.